I'm Dan McGuire. I built this library called Texas. It's attempting to be virtual DOM, but on the server. So kind of a really high level, like what is virtual DOM? Why does it exist? So people say virtual DOM, I guess they're really talking about the code representation of the DOM, but why it exists is more interesting. It allows us to do like operations against some code so that we're not messing with the actual DOM until we know what all we want, and then we can do efficient updates to the DOM. It's generally how client-side frameworks are handling it. On the server side, it's pretty similar. You know, we're just keeping an Elixir representation of the parts that we care about in the DOM. Texas isn't doing like a full cache of the DOM on the backside. It's just the markup. And then it's going to take those dynamic parts, the parts that Texas cares about, and it knows how to do efficient updates when the developer just broadcasts a message out. So yeah, I need to mention my company, RentPath. So RentPath sent a bunch of us out here. I write Elixir at RentPath. We are a distributed team working remotely from all over, so it's cool to see a bunch of these guys. I only hate about half of them, so it's really good to see half of them. Like, this guy right here is awesome. But no, seriously, the RentPath team's really cool. I'm enjoying working with them. This is on. Okay, good. Yeah. So Texas, we'll start off kind of an overview of what the talk is going to do. I'm just going to go through the runtime, like all the request cycles, the messages that are going to touch all the different parts of Texas, and so that'll hopefully give a better idea of what's actually happening. It's relatively simple. The concepts are neat, and maybe there's a lot of things that y'all haven't thought about when you're talking about doing server-side DOM that are really interesting as well. What you're seeing right now is this is the same application y'all are just playing with that's running probably over a little more optimal wireless connection, and so every single one of those operations is going back to the server for a round trip, doing a diff patch and updating each of those clients. So it can be pretty performant. It can feel really snappy. Hopefully with a lot of people connected it can as well. But this is a very alpha library, so I really don't know either. Yeah. Also, GigElixir is really cool. The free tier didn't allow me to do an observer into it, but like by default, you're able to use like a Heroku like build pack, push your application up, and it supposedly gives you like these tools that you can do like observer start and all these things for free that you don't have to set up yourself, which is really cool. And yeah, if you're just streaming in, if you want to check the Whova app, I did post a comment on this talk with a link to that website that I'm not sure how well is working because I can't really see the screens from here. But I didn't hear any oohs and ahs, so I'm guessing it was about what I expected with the Wi-Fi connection. All right, so we'll start off with the HTTP request. Like any web framework, we're going to send a request back to a filing cabinet with Elixir hiding behind it. And yeah, so the first interesting thing that the server is actually going to do is it needs to authenticate the clients immediately. And the reason for that is because if we don't know which client it is, we don't know which cache state to be diffing and pushing up messages to. So immediately, as soon as someone makes a request back, we're checking to see, hey, do you have this UUID? Do you have this Texas identification? Are you authenticated? Do we know who you are? And if you don't, we're going to give you this cookie, and then we're going to proceed to spin up a process that will allow us to cache that state. So the next thing is a very typical server-rendered application. You're probably very familiar with those things. We don't do a whole lot of them in production now. We're using a lot of front-end clients, like heavy client-side frameworks, but this is probably a familiar feeling. It's pretty simple. There's a couple different concepts with Texas's templating engine, and that is that the template is entirely HTML. It's all static content, and then if you want to have dynamic content in there, which is the purpose of having the templating engine, you need to write some function that will know how to merge in with that HTML at compile time in order to give you those dynamic capabilities. So a couple interesting, I guess, key points. My timer started. Fantastic. So a couple interesting key points is that you'll see that inside the templates, the pure HTML, you've got an HTML5 data attribute, and that's telling us that example list is kind of the function that I expect to be rendering out the dynamic parts of my application. And another interesting thing you might notice is that from this function, we're not actually returning an HTML string. We're building up an HTML string, but then we're using a library called Floki to parse it into AST. There's kind of some hopeful, really performance benefits to that, but also the templating engine needs to know kind of like different parts of the HTML to be able to render it out dynamically. So in the future, probably going to just like create a macro that'll be able to do more efficient things with I/O lists and I/O data, right? That's a lot more efficient for backend server rendered applications. I'll talk a lot more about I/O lists later because they're really cool. And a lot of stuff that's cool about this is that Phoenix is really good at backend rendered applications, right? And so this is just kind of maybe a more interesting way to update our clients at a kind of a component level that will allow us to take advantage of all these Phoenix benefits, the actual cool stuff, right? So we've got the full HTTP request response cycle, and we're sending that HTTP response back. But while we're doing that, we need to cache this initial representation. So all of those Texas functions that are evaluating to this AST, we'll send them to a process and save that in the state. We're going to use that later to do the diff and patch again. It's create a patch. The patch is going to be an efficient message that is hopefully the least amount of data necessary to update the client to the state we want it to show, right? So we start up this process. And okay, so the response gets to the client, and we need a persistent connection with Texas. It does heavily rely on having a persistent connection so that the server can push up messages to the client. Way more, potentially, depending on your app, but very likely, more operations are going to be pushed up from the server to your client rather than the client requesting something and looking for a response, right? And the reason for that is because it's very easy in Texas to make sure everything is distributed out to every single client that cares about some property. So, you imagine some user list. User A over here joins, you probably want every single other application to know that that user A has joined this list without them having to make a request. So WebSocket is an efficient, it's a fast connection. Phoenix, again, has an awesome abstraction over WebSockets called channels, so we use that. It's made this a lot easier for me to write. But now we need to update some state. So it's also worth mentioning that Texas is probably more interesting when you think about it as a library that is a good way to update views for your clients. It's a lot more declarative, but we'll get more into that, I guess, later. But right now we need to update some state so that when we broadcast out a message, we have some diff patch, or some patch rather to send up over the wire. So Texas does have the concept of forms that are just HTML forms, and they work as HTML forms, but they're going to wrap those up and serialize that data and send it back over to WebSocket. We have a WebSocket, might as well use it. It's a little bit faster. And it's going to have all the context necessary to treat that exactly as an HTTP request, right? So as soon as it gets to your server, it's going to get routed to the exact same function inside your controller that the HTTP request would, right? So the exact same functions are going to be called, and that has some implications to like how you're going to test your applications as well. So I guess just talking more to that, like integration tests are going to be a lot more easy. Instead of spinning up a headless browser in order to get this WebSocket connection, you can just send an HTTP request, like in the test, in order to integrate do a full integration to see that that specific function is going to render out the server side the data that you expect, and that's an integration test. No more headless browsers necessary, which means that your tests are going to run a lot faster, probably a lot less complex to set up. There's a lot of benefits to that, hopefully. Cool, so we've updated the state, and that's it. Like, that's kind of like, there's two separate parts. You can either update the state, and then the broadcasting the message kind of starts telling the clients which clients need to update themselves, right? So once we update the state, the WebSocket message is done. But as a developer, we said, okay, after we update the state, we want to have those clients that know about that state, that care about that Texas property component, whatever you want to call it. We want to have them re-render themselves to show the new state. So we broadcast out a message, and here we've got 3 processes that apparently subscribe to that topic. Whenever Texas client process is set up, it's going to go through all of the different properties that it cares about, and it's going to subscribe to those topics. So one way to get them to update themselves for that topic is just to broadcast a message with that topic name. So what it's going to do is when it gets that message, it's going to say, hey, I see this topic example list. I know that I care about that view, so let me re-render that view. And when I re-render that view, I'll have the new representation of the state. And then we can diff against the old cached state with the new rendered state, and get hopefully a very small patch message that we can send up to the client that will bring it up to date without us as developers having to write any like transport structures like JSON or anything like that. So this is just kind of some pseudocode as to what a message might look like. It doesn't really look like this, and it probably never will. There's a lot of efficient techniques we can do for like compression and whatnot to get this message down to the smallest size possible, get it very quickly to our clients. Depending on certain properties, you might even be able to configure your application in the future. to use different protocols, depending on kind of what you want your message to look like and the different trade-offs between the different protocols and whatnot. But the message is essentially just saying, hey, for this property, at index 0, we want to delete whatever's there and stick in some new message, right? And so you're done. That is the Texas lifecycle. That is kind of what Texas does. But jumping back a little bit, maybe giving a little context and history will give you some insight as to how this kind of came about, where I want to go with it and whatnot. But so the history, I guess, sort of starts when there's a Ruby web framework that was really heavily targeting view-first development. And as one of the kind of criteria there for view-first development is it really wanted to do, like, get all the static content over here, all the dynamic content over here. Texas template does that by getting all the functions that represent all the dynamic stuff outside of your template so that you can just, as a developer, think, I just want to write HTML and CSS right now. I want to get some representation of my state up. It's a prototype, it looks good, it feels like it'll be able to work, and then like put on a different hat. Now I can go to the back end, write some dynamic stuff, and hopefully fewer context switches means you get to market quicker, maybe less bugs, maybe less complexity like resting in your head, maybe less going back and forth like doing pixel perfect junk, right? So hopefully that's the idea there. But back to Jay Hayes, so me and him spoke a bunch about these different properties, and I think we got into Elixir around similar times. He might have been about a year earlier than me, but we both were playing around with Elixir, thought it was really cool for all the normal reasons that Elixir is cool, and we decided, this would be an amazing, platform to build something like Texas. He had a different implementation than I did, and he actually did a lightning talk on Ratchet and Jank. So Ratchet was like the first implementation of the Texas templating engine was really Ratchet. I just kind of rewrote it so that I would better understand it myself, and I had some kind of different concerns that I wanted to solve with my version as well. And the Jank is kind of his version, which is a lot different than the Texas implementation, but kind of high-level goals are very similar, right? And I think what he's doing, I don't know much about the implementation, I just know that he is kind of taking that dynamic data that is broken out of the static stuff. It's easier to introspect, so he was able to build React views at compile time, so generate some JS such that, he could treat it like a React application with like a backend JSON without the developer having to write all of that transport stuff, right? Of course, with Texas, we're kind of going the virtual DOM on the back end route, so it's a little bit different. But implementation, so Texas did start out just generating JS. There were a lot of edge cases to that. I kept on like having to tweak with stuff and like mark fields dirty and whatnot. Like one of the big things that was I was having to dig into like the virtual DOM implementation is that there wasn't a good way, at least in the library I was using, to say that, hey, this user typing into an input field, like don't erase that. You know that this virtual DOM representation doesn't have any text in the input field, but I don't want you to like blow up their text when they're typing. So there's a lot of little edge cases there, and I knew that that wasn't the most efficient way to go about it. I knew that I wanted to do something entirely different, so I kind of went back to the server side, and now I've got a really terrible algorithm for diff patching that will get better, hopefully. We'll see. That is working, and it seems to be working really quickly. Like reference the GIF, not what you were actually playing with if it was going really slow. I think it can be fast, and I think it maybe is fast now. It needs to be kind of load tested, right? So now we'll go over a ton of benefits. And a lot of these benefits have very little to do with Texas itself and just the fact that it is on top of Phoenix. For instance, Phoenix and I/O lists, Erlang I/O lists are amazing. If you're not super familiar with I/O lists, Nathan Long wrote a 2-part article kind of addressing like a lot of the details about I/O lists. But essentially like the main point I took away from it that I think is the most interesting point is the only place the full response is created is in the socket buffer. So in the context of Elixir, we have immutable data. So just think about how many functions and like references to different parts of memory you'd have to like create an entirely new string because it's immutable. You can't just mutate that string in place. So you're creating a ton of strings just to get to this full HTML representation, HTML string, and I/O lists kind of circumvent that entirely, and they just keep this list that they write directly to the socket buffer. So nothing is ever completely built out. You just kind of hit each little piece of the I/O list is written and streamed down the socket up to the client, right? So it's super efficient, and that's one of the biggest reasons you'll see like those backwards U symbols when you're playing with Phoenix applications, and you're like, I don't know what that means. You have to look it up on Google. Turns out that's microseconds, and those are smaller in milliseconds, and you're like, wow, that's really cool, right? So yay, Phoenix. Yeah, so more control over your runtime. This is potentially a big one as well. If your application is really complex and slow and you can't figure out why, and you're spending a ton of developer time trying to figure out how can we make this more efficient. If it's running on your client, then what do you do? You reach out to them and be like, hey, buy a better phone, like upgrade. Like that's not something you can usually do with your clients. So it'd be a lot easier if this heavy computation is going on the server, right? You just buy a beefier server, like, scale out horizontally, do whatever you do on the server to make it run faster. And that can kind of be a stopgap between, wow, my code sucks, let's try to fix that, but at the same time, spend a lot of money on servers, get it running fast for our users right now. So simplified tool chains for static assets. This is a big one for me, like jumping around from gulp, grunt, of course, Webpack seems to be pretty stable. I'm actually kind of excited about that. I think Phoenix 1.4 is using Webpack maybe, I don't really know. But yeah, we seem to be kind of, the JS community, the client-side community seems to be coming around Webpack, which is really cool. But I've definitely jumped from and learned tons of different tool chains. And if you go to the GitHub pages for these, complex beasts, you'll see that they have tons of issues. They have 100 issues on almost all of them. And that's not saying that those things are bad, that's saying that they're very complex, most of those issues probably aren't even bugs. I don't really know. They're amazing engineering to solve a problem that hopefully we can just circumvent entirely by bringing most of our development back to the server side, right? So faster integration tests with no headless browser. I am probably going to repeat myself a good bit. I wanted to give myself 2 chances to say things the right way. That might not be enough, but hopefully I will. So faster integration tests with no headless browsers. Yeah, again, if you're using Texas forms to push messages back over the WebSocket, that'll work the exact same if you're using HTTP requests, right? It's just going over HTTP and being serialized a different way, a little slower, but it's going to hit the same code. It's going to hit the same code that you've written, so you can test every piece of code that you've written just by on your backend, or your servers rather, writing an HTTP request rather than setting up the headless browser. Declarative approach to building web UIs. So here's the boring definitions of those things that I pulled off of the first Google hit that I saw. I don't really, probably should have attributed the web page, my apologies. Yeah, so whatever web page I pulled that from, and really, declarative and imperative are kind of a scale, right? How imperative or how declarative is something, right? But I would say the most declarative difference between doing client-side frameworks as opposed to something like Texas is that when you are ready, you have your state updated to a point that you want the clients to update themselves. All you're doing is broadcasting a message. That's all you need to know which topics those clients are subscribed to, broadcast out a message such that it hits those clients, and you're done. They take care of themselves. They know which functions to execute in order to get this new state that they can say, hey, well, I know what state lives on the browser right now. I'll diff against it, and they do the diff. They create a patch, and a lot of other magic's going to happen on the back end. It's going to create an efficient patch, hopefully in the future, right? That's going to push up over the wire, and it's going to be super fast, and we're all happy and we celebrate, right? So more efficient transport, again, HTTP is going over a string protocol, whereas WebSockets is binary. We can do any sort of compression techniques, use protobufs or whatever. I don't even know what that means, honestly, but it sounds really cool. So we'll use protobufs or something cool like that, right? And we'll make everything super fast and super small somehow. And there's a lot of techniques for compression, definitely, that I'm looking forward to putting in place and figuring out. Yeah, there's a lot of improvements to be made. View first development. So I guess I kind of went into that with kind of context switching, but I think that's probably a benefit that's going to be highly overlooked by engineers that are super oh, we got to get these fast numbers so we can show it to our friends, right? The microseconds get us all to smile, but then you say, oh, that only took a week to develop, and your friend's like, you're an idiot, I could do that in 3 days, So I think that having this less context switching really can have a huge business benefit, right? It can get stuff to the market faster. You feel less invested in the code you've written, so if you're oh, that was terrible, using Texas was a dumb idea, you just delete all that stuff and just okay, we only wasted a week or whatever. So hopefully less context switching, view first development, all these things. It might be a better process to integrate your designers too, right? So now your designers can, instead of doing whatever designers do, they can write HTML, CSS, and you can reuse that. You can go in, just plug in these data attributes for Texas, and say, okay, this is where the dynamic data goes. It doesn't actually manipulate their prototype in any form or fashion. It's just kind of a hidden target that says, hey, this is where we're going to merge in our code at compile time that will be able to do the dynamic things, right? And potentially far less code. And think I am way ahead of time. Well done. Sweet. So potentially far less code in that you're not writing JSON anymore. You're not targeting these efficient transport structures in order to build them up just to get them to the client side and have to write a lot of code to destructure them and get them into your view. There was a really interesting article that I hope that I'm just not like butchering the entire meaning of, but Mark Johnson wrote something on Hacker Noon. It was a really interesting clickbaity title that like was really informative. I liked the article. How GraphQL replaces Redux. And you're like, at first, how does that even make sense? But really all they were using Redux for is this like, pattern for handling state on the client side because they needed to push that JSON up and then later destructure it into the kind of shape of the data they needed. But with GraphQL, they were able to make very fine-tuned queries to get the exact shape of the data that they wanted. Therefore, they weren't, doing all of that stateful stuff. They didn't need to store any state. They just made the request, and that's my understanding of it. Like I said, I could be entirely butchering what he was saying. My understanding is he was able to make really well-formed requests to get exactly the data where he needed, and he didn't have to store anything on the client side in the first place. So this is kind of the same idea with Texas, is that Texas can kind of make opaque the transport, right? You've got these server functions, like these dynamic functions in the back end that we already can introspect and kind of figure out, hey, what do we need to do in order to update our clients efficiently? And the developer, the application developer, never has to think about that. Hopefully they can broadcast out a message, just be like, hooray, it worked. I don't know what's happening, but our clients can actually see the new code. Fantastic. So there are some considerations with Texas. So one thing that may not be immediately obvious is that Texas needs to fully control the Texas components and HTML subtrees. That'll kind of come into play later too with a future feature that I think the library needs. But really, it's don't unsync the cache. You've got the backend representation. If you're using some client library to manipulate the view on the front end, the backend's never going to know about that. So when you create your diff patches for the new state, like it's going to send out some message that's going to create a bunch of like jarbled junk that your client's going to be super confused what's going on, right? So that sounds really dangerous, but at the same time, these components can be really well contained. It can be really easy to stay away from using them, and there's really no reason you couldn't use some front-end framework right alongside Texas. Like it's not going to just take over your entire application. You're sending up a couple hundred lines of JavaScript at this point. It's not a big deal. Like React's barely even going to notice that it's there. So Texas separates state update and view update entirely. So there are some architectural, like this, optimizations you can make when you think about this from the perspective of you're only going to update your clients whenever you broadcast out the right kind of message. And so let's say you've got like a system where your state updates, like 1,000 times a second or whatever, and so like you trigger like 1,000 of these messages to go out across your cluster and tell all of the clients to update, or you could just send all of those broadcasts to a process, and then once every second, or whatever your use case is, let's say your users are super happy only seeing updates once every second, So once every second, you just deduplicate every single one of those broadcast messages, only send that out once. The state already exists in the most new state, right? And so whenever that message goes out at the end of the 1 second, it's going to tell them to build their view in the context of the newest state. And so, you could have a lot of performance improvements there, potentially, that you could get other ways with other systems, but it seems like it's really easy to do with something like Texas. So I don't really want to be prescriptive with how you do things in Texas because I really don't know how to do them either. But a consideration to kind of keep in mind is that these messages might be going across some cluster. They might be hitting the network. So let's try to keep our messages really small, maybe really simple. And so what does that mean for things like pagination or some of this transient data that we're used to just taking and plugging in as an argument to our view functions, right? We get them from some query param or whatever, and we plug them into our view function and everything's fine. Everything works exactly as we intended. But maybe if we want to keep our broadcasted messages really small, we could just store that pagination data in a process somewhere. Say process A is on page 5, so whenever the view function executes, it knows to reach out to that process. Say, hey, which page am I on? I'm on page 5, great. And so you don't actually pass that parameter explicitly to the view function. Now you can, there are ways to do that. Maybe that's the best way to do it. Maybe it's not. I don't really know. I just write code sometimes, yeah, that's next consideration. This is an alpha library. Be really cautious using this for anything that's actually important. I do encourage you to go have fun with it and tell me all the dumb mistakes that I made. The code base is ugly, needs a lot of tests, that needs a lot of love. I would absolutely love to have any sort of feedback. PRs welcome, all that good stuff, right? So the future, let's talk about, so client-side transitions. I said I'd kind of get back to Texas owning the component. So a big consideration there is that if you can't update Texas components on the client side, then does that mean you have to hit the network just to be able to do something like show a spinner? Well, that's kind of the whole point of showing the spinner in the first place, is that the network might be down, right? The network might be shaky, and you want to let the user know that, hey, you did input something. We registered that you touched a button. You did whatever you did. We want to, change a color, do this, that, or the other. So something that Texas does need is a way to kind of give you a hook to allow you to change inside of these Texas components, such that when a new message comes up that's got the patch that says, hey, I'm going to update this view, it needs to be able to revert back to the original view, the original component of the view, such that the patch can be applied to that and then shown in the DOM, rather than really weird things happening because that patch might be doing all kinds of weird stuff, right? And so it does need client-side transition hooks. So in your client side, probably JS, right, is going to be able to change that, with the caveat that I'm going to be ripping all of that out as soon as the next message comes up. So it's very transition focused, and I think that's a big feature that it needs right now. Better static content tooling. So talking more about view first developments and kind of putting more emphasis on building prototypes in HTML and CSS, I would like to see more interesting tooling around being able to show this prototype view over here, and then here's the actual view that we're working on with dynamic content. Show them side by side, have different servers, whatever, just to make it easier to have a reference point of the actual HTML and CSS rather than maybe just some page. And who knows, you could get really interesting with the tooling, such that this static content might even have some button, you click on it, that goes to the next expected state or whatever. It'd be really easy to kind of inspect the actual application against what this prototype was that you did whenever you're writing HTML and CSS. Yeah, plenty of low-hanging performance improvements. I think I mentioned many times that the messaging protocol has a long way to go. The diff, the diff and the patch created by the diff has a long way to go to be optimal. And I think it's already pretty fast. It's surprisingly quick, even on going over cell phone internet and whatnot. There's a lot of optimizations for the templating engine, so it's quite a bit slower. I mean, we're talking about going from microseconds to sub 10 milliseconds, so it's really not the biggest deal in the world for small applications, but there are a lot of optimizations I think that can be made as far as kind of introspecting that data from the function that's being called in the dynamic data part, introspecting that data and then doing more to create efficient I/O lists with that. Template language at the editor level. So this is just kind of something I think would be neat. Maybe not the biggest deal in the world, but what if every single developer on your team could choose their own template language? Slim, Pug, Haml, whatever. Since this is pure HTML, this would go to across different languages. And they could use this if the editor did that, right? So if you want to write Haml, you write Haml, but when you save the file, it goes to HTML, you check that into code source, everyone's working against HTML, and since you don't have these weird symbols that are saying, hey, this code goes into the HTML at this point or wherever, you don't have to have those considerations, it doesn't have to be language specific. Everything's going to work with HTML sort of deal. Progressive web apps, question mark? So I recently, I think I was messing with a Mastodon, which is some federated something, or Twitter, I think, I don't know. Anyways, it popped up a message at the bottom of my cell phone that said, do you want this web page to be on your home screen? And I was like, oh, yeah, sure, whatever, I don't know. I clicked it and I was like, oh my goodness, this is an application I didn't have to go to the Google Play Store to get, right? So if we can maybe introspect the data enough to get a minimally viable progressive web app, is that going to potentially, these are questions, I really don't know. I hope so. I think it'd be really cool. Create a progressive web app such that, we've got we're targeting desktops pretty heavily, but what if users get used to going to a website via Chrome, via Safari or whatever, and a little pop-up pops up and says, hey, do you want to save this to your home screen? And that's how they download apps now. They've got a button on their home screen they can click. It has the similar, like maybe same user experience for people using that. Like users don't care how they get there. They just want that little button on their phone that reminds them every time they click on the on screen. They're like, yeah, I do have that app. Yeah, I do want to check that stuff. You know, it gets the same target audience. And you'd be using the same code base, right? And so you don't have to have like some native team or some complex, system for getting stuff to the Play Store. It can take a lot of complexity, get to the market faster, better for MVP sort of stuff, maybe more efficient, like updating of the clients in the first place. I don't know. Oh, hey, that was it. Cool. Yeah, that's my talk. That's me. I'm Dan McGuire. These are the links to the GitLab. The first one is Texas. It's the library. You can find the Texas.js link from inside there. But the to-do app that we were playing with earlier is the example Texas app. And yeah, how to get in contact with me best? I don't know. Twitter, Slack. Sometimes I'm on IRC. Like, I'm not super reliable to get in contact with, but I promise if you ping me on something, like, I'll find it and be super excited that someone wants to talk to me. Yeah, I think that's my talk. Y'all have any questions? I can like repeat the question, or do you want me to just repeat the question? I can hear him.
I was wondering, have you heard of Drab?
I have heard of Drab. I've not used it. So Drab, my understanding is it's like a more like specific hook into you would have like some sort of API to push stuff up over a WebSocket. I don't know how similar the development experience would be. Like I said, I have not used it, but glancing over the documentation, it seems like it is an abstraction around WebSockets that allows you to use WebSockets to update the UI, which is really cool. You also go check out Drab. That might be a better fit for whatever you're trying to do. But it did seem like it would be like quite a bit different experience than using Texas. I already know the answer to this is no.
Still hear me?
Yeah, there
Yes.
we go.
Have you measured what sort of memory hit keeping a virtual DOM on the server is going to? Nope. Okay.
Nope, no idea. I should have put like a counter up to see how many people had connected to this, because I was showing the, which I'll go back to it maybe potentially. So there's some information at the very top about what kind of memory is running this live application. I don't know how many people are connected to it, so it's hard to tell how much is actually cached and what the memory hit to it is. Going once.
I'm curious, can you share like DOM parts of it between multiple clients? Like maybe the header is like more shared somehow?
Yeah, so if like you just store the state anywhere on your application, like Texas doesn't really have any opinions on how you store state for that header, and then you just make a next element, and whenever the client connects, it's going to be able to, even if you change the state, it'll push that update to the other clients, and it'll keep them all synchronized. Did we do a conference talk? Question mark? I think we're done. All right. Thanks for showing up, everybody.